The concept of discussion is a dynamic equilibrium. We look at these two words, dynamic and equilibrium. Dynamic means something that changes. Equilibrium means something that is stable, that doesn't change. So now looking at the two words together, we want to say what dynamic equilibrium means in a population. So when we talk about dynamic equilibrium, it's a state, a situation where you have a stability within a living system in the internal condition. That is when the internal condition in a living system is relatively constant despite continuous change, movement, and environmental changes. That is, despite the fact that you have continuous changes, you have sudden changes taking place, the condition or the internal condition is still relatively constant. You have what we describe as balance within biological system. You have a situation in a population where the state of the population size remains relatively stable over a period of time, despite the constant fluctuations in birth and death. That is, despite the fact that we have fluctuations in the birth as well as in the death of certain organisms within the population or within an ecosystem, you have um, a relatively stable, let's say, population size. Let's look at certain characteristics that we can say that can make one to say that, yeah, we have a dynamic equilibrium in populations or in a population. The first one I considered here is a balance of rates. When we talk about balance of rates, why the individuals are continuously being added to the population. Maybe they are being added to the population through births or through immigration. That is, you have reproduction continuously taking place, and you have, organisms adding to the population. You also have organisms being removed from the population through death or through, leaving the population maybe to another place. We have that is being referred to as a emigration. Now, the overall population size shows no significant long-term increase or decrease. That is, in such a population that is described as a dynamic, it is observed that there is no change despite you have birth or reproduction taking place and you still have death taking place or removal taking place. That means that you have a sort of a relatively stable. That is, that particular population is being considered relatively stable because the rates of death is almost equal to the rate of death. So we say balance of rates. Then the next one that is being considered here is what we call a carrying capacity. Carrying capacity, you have uh, a situation where the population oscillates around the maximum number an environment can support. That is, in an environment, there's a state of population. That's a time the population reach a state that that particular environment can support. So at that time, no further growth can take place. That is, they have the limit. They have reached the limit due to available resources. Then we have another thing that is being referred to as a oscillation. That's another characteristic of a population that have reached a dynamic equilibrium. The equilibrium is really perfect. That is, it's really you really get a situation where it is 100%. That is where the input is completely equal to the output. There's usually, a little bit of fluctuations. That is, you don't have a situation where the birth rate, for example, which is being referred to as input, is equal to the death rate, which is being referred to as the output. So we have oscillations, that is, the figure or the situation oscillates. You don't have a situation where the number of the individual organism within that population is directly equal to the number of the organisms in the uh, the number that have just been added is equal to the number that has just been removed. So we don't have 100%. We have oscillations taking place. That is, you have a situation where organisms, uh, organisms are increased in the population and also decreased, but we don't have a continuous, or we don't have a balance. That is, we don't have a situation where we have equal numbers of the two. Now we have what we refer to as a predator-prey cycle. We know predator means organisms that prey on another organism, that is another organism, and we have the prey that is being referred to as the organisms that are being eaten up by another organism. When there is a rise in prey, there's always an increase in the predator, which in turn will cause reduction in the prey, and keeping both population in a continuous balanced cycle. For example, when you have a prey, for example, we have lion as an example of a predator, and a prey for lion, we have maybe something like antelope. So in a situation where you have an increase in the number of lion in a particular place, there's a possibility for us to have a reduction in the prey, that is what they feed upon, like the case I've given to you now, the antelope. So the population, both population now keep at a constant balanced cycle. Then we have environmental factors, external factors such as weather, disease, um, and some other examples influence the balance and cause a shift in the balance over time. You know, we could have environmental factors that are, having influence on the population, but in spite of this, but we could have a situation where it may affect the population, uh, you know, uh, that have been balanced for over time. Then another thing is you have ecosystem maintaining biodiversity in a particular place where you have a dynamic equilibrium population. You have the number of different types of organisms in that particular place are literally at manageable state, that is, without constantly increasing or decreasing or disappearing. So this is what we mean by um, maintaining biodiversity. That is, the number of organisms that are there, different organisms that are there, seems to be constant, though not perfectly 100%. So now let's look at dynamic equilibrium within communities. Now, the other one that we look at was within population. But when we talk about community, a community is where you have different populations within an environment. So it's a state, the dynamic equilibrium within communities is a state or a time, a state, yeah, that we have a balance in an ecological community. The population size of different species, community structure, and biodiversity are stable over time despite constant or small scale changes. That is, despite the changes that we have, you have a situation where you have a stable population size for different organisms. So despite you have the addition, the suppression, despite the whatever the condition, we still have a stable internal environment within the community for each of the populations. So in this case, we are talking about different populations of different organisms. And the real rates of change that, like the birth I've given as example the other time, compared to rate of loss of the organisms in that particular environment, seems to be balanced. Now, let's look at the characteristics of a dynamic equilibrium in a community. We have constant flux. That is, you have a stable structure. We have stable birth, stable death, stable migration, stable immigration of organisms taking place. But the net composition of the community consistently remains the same. That is, we have a birth taking place, immigration taking place, death taking place, the immigration taking place, and in spite of all this, the population still of these different organisms still remains relatively the same. So that's what we refer to as constant flux and stable structure. Then we have what we call a climax community. That's when a community matured to a point of relative stability after succession until there's a major disturbance. That is, actually, when we talk about a dynamic equilibrium in a community, that's when we is indirectly referred to as a climax community. That is when a community has reached a matured point that is relatively stable. That is, most times what you say in that particular community seems to be the same. That is, seems to be the same type of organisms, the same type of species, the same type of biodiversity in that particular area. That's what you seem to have when there is a climax community. But sometimes this is available until when there's a major disturbance, like if there's fire that clears all of them together. So we normally have climax community. Another thing that one can observe in a dynamic community, equilibrium in a community is resilience. A community that has reached dynamic equilibrium is resilient. That is able to maintain functionality over a long period of time. That is, they are able to adapt to environmental pressures. The community can absorb different, well, small disturbances. They can easily cover up with the small disturbances. What I'm trying to say in this case is that when you have little disturbances or small disturbances, maybe like small fire, like storm, it happens, but in that community, they are resilient because after the incident, it's not noticeable in them. So that's another characteristic that is observed in a dynamic equilibrium. Then another thing that we have that I've considered here is what we refer as a role of biodiversity. So there is also high biodiversity in dynamic equilibrium in a community. The the biodiversity actually increases the ecosystem resilience and ability to cover for disturbances. So if there's disturbances because of the biodiversity, different organisms that are there, you have these different organisms being able to cover up for the disturbances so that the disturbance that happens at a particular time will not be noticeable or will not really affect the community. It will just look as if nothing has happened. So this is what we mean by stable or stable community or dynamic equilibrium, either within a population or within a population or within a community. Thank you for listening.